This video shows an example of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this is happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds. And by the completion of our experiment, we should see some very nice separation of the different pigment colors. Now, to do analysis of our results, what we're going to want to do is to measure the distance traveled by each pigment. Let's pause here for a moment. So I want to measure the maximum distance traveled by the water and then by each different pigment starting at the line drawn on the paper. To be fair, we should be comparing the distance traveled by the water starting from the same point where the pigment started traveling. So we'll measure all of our distances starting at this point. Looks like the maximum distance traveled by the water reaches about to here, and then we can measure the maximum distance traveled by each of the different pigments. Let's continue our playback. The final part of our analysis will be to calculate an RF value. This is going to be a different calculated number for each different color pigment. For a pigment which travels exactly the same distance traveled by water, which is the solvent or the mobile phase in this experiment, the RF value would calculate to be 1. That's because the distance traveled by the pigment would be the same as the distance traveled by the water. If we had a pigment color which travels half the distance of the water, the RF value for that pigment would be 0.5.